This is question 8 in exercise 4.7 in Project Maths 3A. Nina is an engineer. She is asked to design a ramp for a mountain bike enthusiast. The site for the ramp is level but sloped as in the diagram. For health and safety reasons, the distance AB must equal 4 meters, the distance DE must equal 7 meters, and the angle alpha must be greater than or equal to 96 degrees. Alpha is shown just at the point C in the diagram up here. For the ramp to meet the biker specifications, alpha must be less than or equal to 108 degrees, BC must equal 180 centimeters, and CD must equal 520 centimeters, and they are both marked on the diagram as well. In order for Nina to meet the requirements, we've got to find the maximum distance between A and E, correct the nearest centimeter, the minimum distance between A and E, correct the nearest centimeter, and then we have to comment on the difference between the maximum and the minimum AE, and which would she choose. So the first thing we've got to pay attention to in this is that the angle alpha that we've got here. So alpha has to be greater than or equal to 96 degrees, and it has to be less than or equal to 108 degrees. So we've got boundaries for it, which means that for the maximum length A to E can be, we need to get the maximum distance between B and D. And to get the maximum distance between B and D in our diagram, we'll need the angle alpha to be as big as it possibly can. So for part 1, to find the maximum distance from A to E, we're going to assume alpha is its max, which is 108 degrees. And then the same reasoning is going to work for the minimum. For the minimum distance from A to E, we want alpha to be as small as possible, because that'll mean that the distance from B to D will be as small as possible. So we're going to take the minimum value for alpha, which is 96 degrees, and we're going to find out those two differences. So let's go through that now. So here we've got part 1. We're asked to find the maximum distance AE correct to the nearest centimeter, where alpha is, this time we're saying 108 degrees. So what we've got is, we've got a triangle with a side that is 1.8 meters, another side which is 5.2 meters. We've got their included angle, and we're being asked to find the distance for the third side. Well, that means we're going to have to use the cosine rule. The cosine rule says that a squared is equal to b squared plus c squared minus 2bc cos A. And this holds for any given triangle. So we're going to be able to use it for this triangle to get the length of our side A, which is the side BD. So we can just call this A for now. Alright, so we're going to fill in the details that we have. So we have A squared is equal to, that's going to be 1.8 squared plus 5.2 squared minus 2 times 1.8 times 5.2 times the cos of 108 degrees, like that. Which means our next line is going to say that a squared is equal to, and 1.8 squared is 3.24, and 5.2 squared is 27.04, and that's going to be minus 18.72 times the cos of 108. Okay, and then if we just tidy that up a little bit, we're going to get a squared is equal to, so it's going to be 30.28 minus, and then the cos of 108 is actually a negative number, which means 18.72 times cos 108 is going to be minus 5.784798.135, like that. So we've got minus a minus number, we're going to add them together. So our a squared is going to be equal to 36.06479813, like that, which means a is going to be equal to the square root of that. So a is going to be equal to 6.00539717. So A is approximately equal to 6.01 meters, because that would be to the nearest centimeter. When we're dealing with meters, the nearest centimeter is 2 decimal places. So that's what we have here. So our distance BD is 601 centimeters, which means that our distance AE from this is going to be equal to 4 plus 6.01 plus 7, which is going to be 17.01 meters, like that. Or 1,701 centimeters would also be acceptable. So that is the maximum value AE can have in this particular diagram. Let's go try and find out what the minimum is now. So the minimum AE correct to the nearest centimeter. In this case, we're using the value for alpha as 96 degrees, because that's the smallest it can possibly be based on the specifications given in the question. So we're going to set up the cosine rule exactly the same as before, calling this side A, this side 1.8, this side 5.2. So A squared is going to be equal to 1.8 squared plus 5.2 squared minus 2 times 1.8 times 5.2 times the cos of 96 degrees. We've already worked out some of these numbers from before, so this can go a little bit quicker. 1.8 squared plus 5.2 squared is 30.28. And then 2 by 1.8 by 5.2 is 18.72. We've already figured all that out from before. So 18.72 cos of 96. Okay. So our next line down, we're going to have 30.28 minus, and this time again we're going to get a negative value for cos. So cos 96 is going to be a negative value. So when we multiply by 18.72, we're going to get minus 1.956772832. So minus minus means it's going to be added together. So when we do that, we're going to get 32.236772283, which means A is going to be equal to the square root of that. So A is equal to 5.6777433639. So A is approximately 5.68 meters, which means that the minimum for AE in this question is going to be 4 plus 5.68 plus 7, which is going to be 16.68 meters. 16.68 meters, or 1,668 centimeters, if you know the way to present that. So that's how that would work out. And now for the third part of the question, we'll go back up to the top. We're asked to comment on the difference between the maximum and minimum A and E. Well, the two values that we have got a 33 centimeter difference, and which one would Nina favor just depends on what she wants to go for. For health and safety reasons, alpha has to be greater than or equal to 96, which suggests that the larger the angle is, the safer the design for the ramp will be. So she might go for the maximum value for more safety. But you notice that for the ramp to meet the biker specifications, they gave an upper limit, which means that a smaller value might be what they need more. So if she goes for the smaller value, it could be more what the mountain bike enthusiasts are after. And that's all you would have to say in that particular question. And that is that.